Good morning. Welcome to Good morning. Welcome to Complex Numbers. Today we'll be working through some non-real numbers in college algebra. This is our second lesson in college algebra, and hopefully this will be a pretty short one, and it'll help you with some stuff that's going to come up way later in the class. So, before we get started, like always, classroom creed. Remember, you know what's cool? Saying the creed. You know what's not cool? Failing college algebra. So, sitting in your room, mom's downstairs, say it real loud so mom hears, like, what are you doing? You're like, oh, I'm saying the classroom creed. And she's like, why? Like, because I want to pass college algebra. Okay, here we go. Today is a new day. I can read and remember well. I'll develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not be easy, but it's worth it. All right, let's go. Let's get started. So, today we are talking about imaginary complex numbers, what those look like, what the difference between a imaginary number is, what a real number is, all these weird things that kind of don't make sense and we've never heard before, but it should be pretty fun. So, let's make this a little smaller, maybe. Boop, boop, boop. Perfect. All right, what is an imaginary unit? What is an imaginary number? Well, it all comes down to this thing that has a little I on it. Anytime you see an I next to a number, you're like, oh, that I stands for imaginary. And when do we get these? Well, we get these, if you look at this definition, the first one, anytime you have a negative under the square root. Now, it says -1 right there, but it doesn't have to be -1. We can use properties of square roots and exponents to realize that any negative under a square root yields an imaginary number. So they kind of say this really cool thing where I equals the square root of -1, which means if you square both sides, cancels out that square root, I squared equals -1. That makes sense. Now, there's this really cool thing that we don't get to yet. We might have time to get to about the cyclical nature of this and what happens if we keep going. So what does that mean if we keep going? This is just to explore a little bit. What about I cubed? What happens if we do one more step? What happens if we multiply by I again? Well, that's just the same thing as I squared times I, right? And we have both those definitions right below. So wouldn't that just be -1 from that right definition and the square root of -1 from that left definition, right? So that gives us something like negative the square root of -1. Okay, well, that's interesting. It's a little weird. But then this is where it really gets cool. So where something really cool happens. What happens if we do it one more time? We go I to the fourth. Well, I to the fourth, we take that I cubed, negative square root of -1. We multiply it by I, which is the square root of -1, right? Because it says that right below. And we get something like negative square root of -1 times square root of -1. And we know the square root of anything times its square root of that same thing, like the square root of 2 times the square root of 2 just gives you 2. So that's just going to give us negative -1, which is just +1. Holy moly. And we're back where we started. So if we go to I5, and then we'll be done. I promise, then we'll be done. If we go to I5, and we multiply I4, that blue thing, which is just 1, by I, which is this purple thing down here that I'm underlining right now, we're back at the same thing. I5 and I1 are the same. And if we keep going, we'd see that, oh, I6 and I2 are the same. And I7 and I3, so it just keeps going over and over, and it repeats on a cycle of 4. Every 4 terms, it's going to repeat. Don't know if that's going to come up. Just a cool thing to think about. And to help you remember, okay, if I see an I with a huge number as an exponent, I can still solve it the same way I solve everything else. All right, let's keep going. So we're going to use some properties of square roots to solve these problems and to kind of see, not necessarily to solve, but to reduce. So if we reduce this thing, the square root of -25, it's like, my 4th grade teacher said, or 6th grade teacher said you could never have a negative under the square root. Now we can. I'm telling you. You couldn't have one. Now you can have one. So we got -25. Well, what we're going to first do is break up that square root and say, I'm going to break it into a million different things. As many little things as I can. Or prime factorizations. If you remember that with those little trees where it looks like this all the time. Yeah. So the first thing, because we're working with imaginaries, I know I'm probably going to get rid of that negative sign. So I'm going to break this down into -1 times 25. Everybody okay with that? I'm okay with it. I think it looks great. And now what I'm going to do is I'm going to use the properties of square roots, which is really just a derivation of the property of exponents. I'll make a note of that later today, to see that this is actually the same thing as the square root of -1 times the square root of 25. Well, we know both of those. And the square root of 25 turns into 5, because 5 times 5 equals 25. And the square root of -1 turns into I. So we're left with I times 5. And if we rewrite it a little bit, because we like to keep the I at the end, it's going to turn into 5I. Not too crazy? I'll let you do B by yourself. Oh, well, we can look at B real quick and know. Look at that. The 2 stays the same. What's that square root of -1 turn into? Probably a I. And we're left with just 2I. Okay, there you go. You're welcome. All right, not too crazy. So that's kind of this thing where we can look at the imaginary unit and how it can break down. You will see that quite a bit, whether it's at the end of a problem. So you did a long problem later in this class, and then at the very end of the problem, you still have to know the properties of the imaginary unit. Okay, now sometimes we put them in a number, because that's not really a number. That's just a little part of a number. Sometimes we put it in this whole big number called a complex number, which has 2 parts. The complex number, this long definition right here, just basically says there's a real part and an imaginary part. There's a number part and an I part, like you can see right below. So, quick label. This 4 right here, you can guess, is the real part. And this 6I right here is the imaginary, just a label, part. It is important, though, to note, like it says in the paragraph above, if that B or that imaginary coefficient is 0, well, then it just wipes out that imaginary part and you're left with just a real number. So it's really not a complex number anymore. Same thing with those pure numbers. If the A or the number part is 0, well, we've got a pure imaginary number, not a complex number. So just a quick little side note on complex numbers. Not too crazy. I guess this next thing is just to kind of look at moving around parts to try to get all the imaginary stuff together. So like on this next one, B, if we were to subtract 2I from both sides, kind of like we did last week, we'd be left with 0 equals 0. Holy moly, that's a tautology that we talked about last week. We talked about the 3 types of equations. That is an always true equation, where the solution is all real numbers, or every number works as a solution. That kind of X is in the set of all real numbers, which, I don't know, it's pretty cool. All right, so let's look at adding and subtracting complex numbers. Promise you this is going to be super easy. So, and it's going to be good practice for us, because we're going to treat the I when adding and subtracting, not when multiplying, because it works a little bit different. There's a little extra step. But when adding and subtracting complex numbers, we're literally treating the I like a variable. We're going to use these 2 rules right here, where you take each part and you combine like terms. Combining like terms is when you take the variable and you add or subtract it to the same variable, not to different ones. So you can see right here, they take the BI and the DI, and they combine them to this other green part. And then they take this blue part, squiggly A, squiggly C, and they combine it to AC. Not too crazy? Well, let's see how it works. So we take this, I'm going to do one of these negatives. Help us with distribution a little bit. You're welcome. I'm only going to do one, though, and we're going to leave the whole back end of this for you to do by yourself so you can explore and learn, even though they're a little bit different, because we really want you to start taking a hold of this learning. So let's see what happens. So we're going to take the blue part, and we're going to say, does anything else look like that blue part? I think this kind of looks like that blue part, right? And then we're going to take this green part and say, does anything else look like that green part? Well, this kind of does right here, right? And then we got this one thing in the middle that looks a little different. It's a negative, right? And technically, anytime you see that negative, there's an invisible 1 right in front of it, and we're just going to distribute that invisible -1 to both terms, that distribution property that we always talk about. So we got -5 plus I minus a -11, which turns into +11, minus a negative 6i, which turns into a positive 6i. I'm going to keep those colors the same. We'll go blue, blue, green, green. And we're going to say, let's combine the blue things. 11 minus 5 turns into a blue 6. 6i, positive, plus 1i, positive, turns into a 7i. Got a plus sign in the middle. And there's our real part of 6 and our imaginary part of 7i. Not too crazy? Pretty easy, right? So that it works with adding and subtracting the same way. The subtracting, you just have to remember that distribution, and that's it. Awesome. Let's keep going. Ooh, they do throw in a little multiplication there. I think I threw that in a little early for you. But there's the definition right there, so we'll work F together. So the conjugate of a complex number. Oh, no. We can do F by ourselves. We can do F by ourselves using the FOIL method, which we talked about earlier this year and in high school, and you've heard it a million times. That first, outer, inner, last, which I'm not doing for you, but you can do completely on your own, and I believe in you. The only thing to think about, I'll leave a little note as you work on it on your own, and you ask questions in class, would be on that last term. The last term is going to be the only tricky one, because when you get to a 4i times a negative 7i, you're probably going to get something a little wonky, like negative 28i squared, and that's where we got to rope in our prior knowledge and say, wait. We don't want I squared. We know I squared can be simpler. What can I squared be from the very beginning? I'm going back to the top. What can we rewrite I squared as? Looks right there like I squared is the same thing as negative 1. So when you get to this last step on this problem, I'm not doing the whole problem for you, but when you get to this last step, that I squared can get rewritten as a negative 1. Turn this into a positive 28 for your last term. So you can do the whole FOIL. If you need help with FOIL, come to office hours, send me an email, watch the video above about FOIL and box method, because if you want to do box, that's fine too. But that would be how we'd work that problem. A little hint, not doing it for you, because we're going to move on to the conjugate of a complex number. So this is where it gets real fun. This is where it gets crazy. The conjugate of a complex number is basically that exact same number or complex number, but with a flipped sign. So the conjugate of a minus bi is a plus bi. Here, I'll square that right there. And vice versa. The conjugate of a plus bi, it works backwards, is a minus bi. All right? So here's the question. Why is this important? I wrote that on the note right there. Why does anybody give a crap about a minus bi, a plus bi? Why do we have to pick that one perfectly? Well, when you do the multiplication, so let's do just one of them real quick. When you do the multiplication, you probably get something like a squared, that's our first term, FOIL, plus our outer term turns into, well, it's going to be negative, minus abi. That's our outer term multiplied. Inner, positive abi. Last, negative bi squared. Holy smokes, look at that. Middle terms cancel. The I squared we literally just said for the note for that last problem turns into a negative 1. That negative 1 kills that negative sign in front of it and turns us into a squared plus b squared. No. Yeah, no, that's right. A squared plus b squared. Oh, yeah. I missed that square. That's my, see, I make mistakes all the time. It is okay to make mistakes as long as we look at them and acknowledge them. So when I multiplied, I'm going to go ahead and zoom in so you can see that mistake and say it's okay to make a mistake as long as you see it and fix it and name it. You name that mistake. So the mistake I made was when I multiplied bi times negative bi times negative bi. Should the b times the negative b turns into negative b squared, and the I times the I turns into I squared. That was my big mistake. My mistake. It is good to make mistakes as long as you catch them and fix them. All right, so that's why it's cool. It got what cool thing happened there? This really cool thing. So all day we've been talking about complex numbers, and then we just learned a tool or an identity that can get rid of all the complex numbers. Look at this. There's no I, and that's way better for us because we hate the I. The I makes it all tricky and not fun. So let's do this with the complex number right here. We'll do a. And then I'll leave you to do the rest. And then I think we'll do one more thing. So right here. So what's the complex conjugate of the only I part, which is the denominator, the only complex number here. I don't think, oh no, they have a complex on the top. So this is important too. When we're doing these problems, this is all new, we're going to take the denominator, because we want to get the I off the bottom, and we're going to multiply by the complex conjugate. So multiply by 4 minus I. Okay, well, can you just multiply by a random number? No, the only number you can ever multiply by for fun, just because you can, is 1. 1 times 1, 1. 2 times 1, 2. 3 times 1, 3. 1,406 times 1 is 1,406. So you're always allowed to multiply by 1. So if we're going to multiply by this 4 minus I on the bottom, what better be in the top? 4 minus I. We're multiplying by 1. We're not multiplying by the complex conjugate. We're multiplying by the identity, or 1, that's made up of the complex conjugate. So here we go. The top, we're going to do our classic distribution. I'm telling you, it always happens. Always, always, always distribute. If you can't distribute, come to office hours. I'll print out a billion distribution problems and we'll just work them. So we've got 12I minus 3I squared. Oop, I see an I squared. I'm going to replace it, just not quite yet. And then on the bottom, we could do that whole identity thing. We could work it out. We could distribute or FOIL. Or we could know the middle terms are going to cancel. I'm going to be left with 16, right? Because 4 times 4 is 16. And then I'm going to be left with plus b squared, which is I squared. So I'm going to be left with plus 1 squared, which is just 1, right? Okay, if you don't see how, I know that went fast. So if you don't see how I got that, I'll do it right next to it real fast. So this is going to be 12I minus 3 times negative 1 over, and the reason we got down to 16 plus 1, which is just 17, was because we did 16 plus, actually that'll be mine, no, that'll be plus 4I minus, and that I squared we just said is literally just negative 1. So that I squared, those two middle terms canceled out, and that I squared turned into a positive 1. That's where we got it from. So now we're left with 12I plus 3, because negative 3 times negative 1 is positive 3, all over 17. Awesome, awesome, awesome. Can we reduce that? Can we turn 12 and 3 into 17? No. Can we do 12 divided by 17? No, 17 is prime. Can we do 3 divided by 17? No, they're both prime. So it looks like we are good to go. We are good to move on to the next one. Okay. 12I plus 3. So we're left with 12I plus 3 over 17. And now what we're going to do, because this isn't in the same form that we started with, is we're going to break it apart. We're going to get it into that complex number form. So we're literally just going to split up the two sections, go chunk, right in half. And we're going to be left with on the imaginary side. Well, we'll start with the non-imaginary. The real side, the real numbers, the real part is 3 over 17. The imaginary part is 12 over 17I. And we'll write our answer like that, because that's a more accurate answer to show us the two parts of the complex number. Now I know it looks messy, but that's a complex number. That is a good complex number that can't be reduced. All right, last but not least, sometimes the principal square root of a negative number for any... All right, so the principal square root of a negative number for any positive number b, any positive number ever b, the principal square root of the negative number of that b is just multiplied by I. So what does that mean? I don't know. That looks a little weird. Let's just show the exact way that works out. We've already seen this earlier in the lesson. But what this does is let you know, oh, I can just take out that I. So literally, this is the cool thing. It's like a shortcut basically, where we can take this negative square root of 8. I don't know. Let's do 7 because it's prime. Take that negative square root of 7 and be like, okay, my shortcut here is I see a negative under the square root. You know what I can do? I can just yank that negative out and turn it into an I, and then it gets rid of it. So that means the simpler form, negative 7 square root turns into I square root 7. Boom, done. You can just take that negative inside, yank it out, turn it into an I. And the identity or the property for that really comes from it being negative square root of b equals -1 times the square root of b. And then that -1 turns into I square root of b. So that's where it comes from if you're interested. If you're not interested, know that little shortcut. And at least maybe you can get a few points on the test or the quiz. If you know that shortcut and you can pull that I out, say negative under the square root, that turns into an I outside the square root. All right, now here's the cool part. Is for the next 5 problems, some of them are a little different than what we've done. Some of them are a little unique in the way they look. Like E, for example, looks a little tricky. But you have all the tools you need to do them. So what we're going to do is we're not going to the book and finding the answers. We're not Googling. We're not going on PhotoMath to find the answers. Your brain is going to try to take what we've learned, recall it, and then apply it to new types of problems that are a little bit different than what we've seen. And when you get stuck, send me an email or post it to the class discussion or do something to learn instead of just putting the answer down. I do not care about the answer. I'll say this every day, 100 times a day. I could care less about the answer, but I do care about you learning this stuff. And you learning this stuff looks like wrestling with it, fighting with it, and trying to understand it. You learning it does not look like taking your phone, snapping PhotoMath, getting the answer, and writing the answer down and being done. Like, what does that do for anybody? That doesn't do anything. Sorry, that's my rant. I'll say that till the day I die. Learning isn't PhotoMath. Learning is wrestling with the problem, getting it wrong 100 times, and getting it right once. All right. Thanks for watching this. Thanks for coming to class. Make sure you are working through these problems. You can work through the practice problems on my website. Actually, since it's a shorter video, this is a good time to look at this. If you haven't seen it, here's my website. And if you click on College Algebra or Pre-Cal, if you're in Pre-Cal, if you click on College Algebra, you can look through all the stuff. You can click on our classroom creed to memorize it for extra credit. Should pull it up. Yep. If you want to look at some suggested homework, not for a grade, posted week 1s already. I'll be posting that weekly. If you want to check out the announcements, here's a link to set up the homework. What else we got? Now we got the syllabus if you want to look at that. My office hours right here. And if you're really interested and need to email me because you're so confused about a problem, there's some email that you can reach me to. So, thanks for watching. Have a good day. Go learn some math. Work on those extra problems. And thanks for letting me work a little math with you. Hope we can do it some more.